Okay, so we're on Unit 6F, the second half, part 2 of the lesson. This is the homework from the other night. Just to remind you, we're talking about two sample z-tests for difference in proportion. So two prop z-tests. It's the shortcut for saying that. Remember, the null is always 0. We think there's no difference between these two proportions, right? If you subtract them, you're going to get 0. So the null is 0 every time. Okay. The Helsinki Heart Study recruited middle-aged men with high cholesterol levels but no history of other serious medical problems to investigate whether a cholesterol-reducing drug could lower the risk of heart attacks. The volunteer subjects were assigned at random to one of two treatments. 2,051 men took the drug gemfibrozil to reduce their cholesterol levels. A control group of 2,030 men took a placebo. During the next 5 years, 56 men in the gemfibrozil group and 84 men in the placebo group had heart attacks. Okay. Do the results give convincing evidence at the 1% significance level that gemfibrozil is effective at preventing heart attacks? So they'd use 1% probably just because it's kind of a life or death situation. This is a big deal, so we want to make sure, it's hard to reject here. They're reducing type 1 errors. Okay, so the null is, we think it's 0, right? It's always 0. So I like how they used a kind of a subscript there, P of G subscript, and then P of placebo or PL there. And then that's the null. The alternate, you could write different way. You could say, we think the rate of heart attacks are going to be less for PG than PL. So PG less than PL. That's the way I would probably write that one, but they did it that way. I'll show you the other way in just a second. Don't forget to define the parameters here. Not P hat, but these are P's. So P sub G is the proportion of men, middle-aged men with high cholesterol, who took the gemfibrozil drug and measured. So the heart attack rate. Oh, so they measured the heart attack rate. So the proportion of middle-aged men, like the ones in the study, who took the drug, and what their heart attack rate was. And then the PL is the heart attack rate for the ones who took a placebo, the middle-aged men who took a placebo. Don't forget to mention the alpha is 0.01. I prefer probably the null to be written this way, so it's 0, just because it's always 0. And again, you could have written that. Oh, they say you could change the order as well. So that'd be fine. So lots of people put a different order. They didn't specify the order, so you can do that, and that'd be fine. Do the results give convincing evidence at the 1% significance level that gemfibrozil is effective at preventing heart attacks? So here's the data here. Let's work this out. Okay, so first of all, we're talking about proportions, obviously. So this, and there's two of them, so it's going to be, so let's see, this is going to be a 2 prop. This is called the name the interval, Z interval. Okay, so what are the conditions? So random, usually I'm looking for something like random sample. Let me look at the whole problem there. So, we're assigned at random to one of two treatments. So this is an experiment, right? So sometimes the wording really, if you didn't catch it the first time, like, okay, what's the first condition? We're going to say random assignment for both groups. So for the PG and the PL. For both groups, you need to say that kind of in words, but that's the idea of it. I'll show you what they said in a second. Less than 10%. So what number is less than 10% of what number? So let's see. So 2051 is less than 10% of all men who have high cholesterol. And 2030, you have to check both groups, is less than 10%, less than 10% of all men who had heart attacks. And then, so let's check the, remember this is for 2-prop z-test. We do a special thing, right? So get your calculator out. Let's try it here. So we're going to go to calculator page and type a fraction. The successes on top, so that's going to be 56 plus 84. The totals on the bottom, 2051 plus 2030. I like to put a decimal, so it gives me a decimal. Okay, so p-hat pooled, so we're going to use p-hat pooled to 0.0343. So p-hat combined is 0.0343. I need that to check my condition. So the first one is 2051 times 0.0343. That's p-hat combined. That number should be greater than or equal to 10. It must, well, let's check it out. So times 205, 2051. 70, yeah, that's bigger. 2051. There we go. Barely fit in there. Okay, and then the next, we have to do the next one. So that would be 2051 times 1 minus 0.0343. And that has to be greater than 10, okay? And then 2030 times 0.0343. And that has to be greater than 10. And since it's bigger, it's certainly going to be than 2030 times 1 minus 0.0343 has to be greater than or equal to 10. So you check it for all four to see what they did. If they did it about the same. They call it a more formal name. I just call it 2-prop z-test. It was an experiment, so randomly assigned to the two groups. Use p-hat combined. And so they checked it for all four. And, wait a second. Don't forget, we didn't need to do this. Why don't we need to do that? Because it's an experiment. So we're not sampling without replacement. We really should have remembered that. So really easy to forget that. Okay, let's try to do the do section here. So I'm going to put a big fraction, z equals, in the numerator, I'm going to do, we're going to do g minus placebo. So g was, I believe it was 56 out of 2051 minus, this is all the statistic here. So 84 divided by 2030. And then we're going to subtract the parameter, which is always 0. Yeah, that's right. And then in the denominator, you're going to have like two fractions added together. First one's over 2051. Second one's over 2030. Probably been easier if I converted these to decimals. It's probably the easier way. I just didn't want to get out my calculator. 2051 times 1 minus 56 2051. Sorry, got a little. Then the next one was 84 divided by 2030 times 1. Their formula looks slightly different than the way I'm writing it. But it should work out the same. So let's see what z is. So they did the work. They used decimals. It's a smart move there, by the way. so they mentioned this because it's negative. So actually the people who took the real drug there actually had less heart attacks, right? So you get a negative number when you do the G proportion minus the placebo proportion. They plugged in the formula. Again, they plugged in a slightly different formula in the denominator. It's the same formula, they just wrote it different. They get Z equals negative 2.475. So let's see what that looks like here. So if you draw the normal curve, there's 0, 1, 2, 3, negative 1, negative 2, negative 3. It's easy to do here. So negative 2.4, so somewhere in there, so almost 2.5 standard deviations below the mean. So there's your shading. I like to draw that out. It's definitely a one-sided test here because we think the GL is going to be, remember the alternate is proportion of G is less than the proportion of PL. So we're going to do norm CDF. Lower bound is negative infinity. Upper bound is negative 2.475. And the mean is 0. Standard deviation is 1. So you're going to type that in your calculator and you're going to get something like this, 0.0065, so 0.6%. Ooh, smaller than 1%, right? That's interesting. We also could have done this in our calculator. So let's just kind of do that. And some of you still are not double checking your work with this. It's definitely what you want to do here. So I think it'll even give you p-hat pooled if you forget, like, hey, I think it's going to be there. So let's go to menu, 6, 7, that's test, then 2 prop Z test. So the first one, I like this. This is easy-ish to do here. 56 out of 205.51, and then 84 out of 2030. And I think the alternate was, we think it's less than, right? The G is less heart attacks. So it gives you p-hat pooled as 0.0343. That sounds familiar. It gives it p-value 0.6%, 0.6754. And then it gives you z-value negative 2.47. Again, this is really the key. If you forget about, if you forget, you're like, wait, is this the one that combines, p-hat combines? Do you see it just says p-hat? That means p-hat combined there. I wish they said p-hat C there, but it is what it is. So it gives you all the important numbers. You got to double check your stuff. So if you're not doing that, you got to start doing that. It really, that's the way most students are doing it on the actual AP. Do the results give convincing evidence that it is effective? Well, let's see. Because the p-value of 0.00675 is less than the alpha level of 1%, we do reject the null. We do have evidence to say that this drug is effective at preventing heart attacks. For men like these who take, than for those who take only a placebo. So for men like these, it's hard to generalize because these were volunteers, these were not random sample folks, but we can prove cause and effect effectively, potentially here. So that's really cool. Do the results give convincing evidence that is effective? Wait, I thought we just did that. Oh, interpret the p-value. So interpret the p-value. So assuming the null is true, assuming that there is no difference between the placebo and the Gemfrazi drug, then there's a 0.68% chance of getting a result of that we got or more extreme. Let's see what they wrote. The difference. Okay, so assuming Gemfrazi is equally effective, assuming there's no difference, there's a 0.68 probability of getting a difference in heart attack rate for the two groups of negative 0.0141 or less by chance alone. So again, where did that negative 0.0141 come from? Let me just show you. Here it is. It's the top of, it's right there, the top of the Z formula there. That's where that came from, I believe. Let me see if they, I think they wrote it down somewhere. Maybe not. Maybe. They didn't. I thought they had it written, like the difference. Looking for it anyway. I don't see it. You just have to subtract the numerators of the Z-score there. Okay. There's a few more practice problems if you want to do them. Interpret the p-value. Is there convincing evidence? So there's the work for that one. The bottom there. There's the bottom. Interpret the p-value and the true lesson.